Welcome in episode number 7. Today we will start implementing our game scene, so we will make use of all of the data we have implemented so far and we will display our grid to the player. If you want to help supporting this channel, consider subscribing so you will not miss any future releases. Okay, so let's get started. Let's open our project, and first thing we need to add our game scene. So I will go to the scenes folder, right click, create, and then scene. Let's call it game scene. Now let's open that scene, and first thing we need to add this scene to the build. So go to the file, build settings, and then grab this game scene and then drop it in the scene in builds. And make sure you have the same order, so the first scene should be main menu and the second one should be the game scene. Okay, once you've done that, let's add the canvas to the scene. So in the hierarchy I will right click, UI, canvas, and then let's set the canvas, the render mode, to be screen space camera. Grab the main camera and drop it into the render camera, and then canvas color, let's change it to scale with screen size. The reference resolution should be 1080 by 1920. Okay, and then let's change this match value to be 0.5. So now let's go to our main camera and make sure the camera is orthographic and the size is 5, set to 5. Okay, now let's add background to our scene. So I will right click on the canvas, UI image, let's call it background, and then let's go to our graphics folder, and you should have the background image. So I will just grab this image and drop it into the source image, and then press this set native size. So you should have background in your scene. Let's add the rest of the UI elements. So first one will be the back button. So right click on the canvas, UI button. I will call this button back button. Let's go to our game scene, graphics, and now you have the back image. So select the back button, drag this back onto the source image, and then press set native size. And we need to remove the text. As you see, there is a text behind, so I will just reveal this text component, select it, and then delete it. And let's move this button. Let's actually switch to the scene view. And then let's grab this button and move it on the top, somewhere here. Okay, so we have our back button. Let's add the clock. So I will just right click on the canvas, create empty, and I will just call this object clock. Right click on the clock, UI image. I will call this image background. Let's grab the timer background sprite and drop it into the source image, and then press set native size. And then let's move it on the same height as our back button. So I will just select the back button, copy this Y value, select the background, and then paste the Y value. So everything is on the same level. Now let's select the clock again, right click, UI image, and I will call it clock. This is going to be the clock image, and we have the slice 1, should be named clocked, but doesn't really matter. So grab this clocked icon, clock sprite, and drop it into the source image, set native size, and then let's move it on the same Y position as our background. So this is 871. Okay, and then let's move it to the side, somewhere here. I think we can scale up the background a bit, so I will just select this background, and on the Y scale I will just set 1.2. Okay, I think that looks okay. So now we can start working on our grid, but first of all let's save this scene. So file, save. And before we start to adding our grid to the game, first of all we need to create one more data. So let's go to our scripts folder, then go to the scriptable objects, and then let's right click, create C# script, and I will call this script game data. Okay, let's open this game data. As you see, I'm using different editor now. This is Rider editor, so it's not Visual Studio. It doesn't really change anything in terms of the tutorial. It's just to edit the code. So I'm not sure if I'm gonna stick with it or if I'm gonna go back to the Visual Studio, but so far I'm quite happy. Okay, so let's start implementing this class. First of all, let's remove all of this start and update function, and then let's inherit, instead from mono behavior, we're going to inherit from the scriptable objects. Right at the top, let's add a few attributes. So first one will be system.serializable, and then another one create menu asset. And now let's add two public variables. So first one will be public string selected category name. We're going to make use of this variable later. And then another one will be public board data selected board data. Okay, that's it, what we have to do in this class. Let's save everything, so just press the save. And now we can go back to our Unity. Let the Unity compile the script. Let's go to our resource folder, data. And now right click inside this data folder, then create. And now you should have the game data option available. So let's select this game data, and I will call it current game data. Okay, and let's initialize this current game data with some values. So let's press this small padlock so we will not miss this inspector. And now let's go to the puzzles. And we have just one puzzle created. So I will just grab this puzzle one and drop it into the selected board data. Okay, so we're gonna initialize it with something. This is just for this episode. Later on, we're gonna implement the proper categories. So this data will be assigned automatically. Once you've done that, let's unlock this padlock. Let's select this current game data. So everything is initialized. Let's save it. Now we need to create two classes. So let's go to the scripts folder, then right click, create C# script, and I will just call this script WordsGrid. Okay, let's add another class. So right click, create C# script, and let's call this script grid square. Okay, let's open this WordsGrid class. I will just remove these comments. So right at the top, let's add public game data. So we're gonna capture the instance of the game data we just created, and let's call it current game data. Another variable will be public game object, and this is gonna be the grid square prefab. And then another will be public alphabet data, and let's call it alphabet data. Okay, then let's add some variables. So public float square offset will be equal to 0.0f, and then public float top position, and then we need one private variable, so it's going to be private list of the game objects. and I will call it square list. Will be equal to new list of the game object. So this is all variable we will need. So now let's actually remove this update function because we will not need it in this class. Let's create a function private void spawn grid squares. Okay, and now let's start to implementing creation of our grid. So let's first of all check if our current game data is not null. So if the current is not null, so if we have assigned something, and then before we continue with this implementation, I think we will need to create two more functions. So first one will be to actually calculate the scale of our square. So as you see as you remember in our editor, let me quickly switch to the Unity editor. Let it compile. If you go to the data and the puzzles, you see we can set the different data for our puzzle, different size. We can even set 20 by 20. Because our code will generate this grid based on this data from the inspector, we need to calculate the scale of every single square. Because if you have more squares on the board, you need to scale them down in order to fit them on the screen. If you have, let's say, 5 by 5 grid, the scale for the single square can be 1 or even bigger. Okay, it's really up to you. The code in our class need to actually cope with this changing of the size. This one 10 by 10, and let me fill up with the random. Let's go back to our code. And below this spawn grid square, we will add one more function, and I will call it private vector3 get square scale, and we will pass the vector3 default scale. Okay, and then let's create some variables. So var final scale will be equal to default scale, and another variable will be var adjustment will be equal to 0.01 f. So this is the adjustment, is the value how much we will scale down or up specific square based on the iteration. So we will see in a minute. So while, okay, let's create the while loop. While should scale down, final scale, and we don't have this should scale down function. So let's quickly add this function in. So below this get square scale, we're going to add another function, which will be private bool, and let's call this name should scale down, and then let's pass the vector 3 target scale. So this function will check if our squares, if the whole board will be fit on our screen. If not, it's gonna scale down all of the squares until they can all be displayed on our screen. So first of all, let's add a few variables. Var square rect will be equal to grid square prefab dot get component sprite renderer dot sprite dot rect. So we're going to capture the size of our sprite. So var square size will be equal to new vector2, and we want to put 0f, 0f, and then var start position will be equal to new vector2, and then let's put 0f, 0f. Okay. So now let's calculate the square size. So square size dot y will be equal to, let's open the braces and let's put the square rect dot width times target scale dot x plus square offset. Okay, the square offset should be outside of the braces. It should be actually square x. Make sure it's a square x, okay, because we're calculating the width. And now let's do the same for the square size dot y will be equal to, let's open braces, square rect dot height times target scale dot y plus square offset. Okay, so we have our size. Now let's calculate the medium of our width and the height of our grid square. So var mid width position will be equal to, let's open 3 braces, and then first of all let's get the current game data dot selected board data dot columns times square size dot x, and outside of the braces put divide by 2. Actually we don't need one pair of the braces, so we need just 2 braces. Okay, and then outside of the braces times 0.01f. And then let's do the same for the height. So var mid width height, maybe the name is not the best, open 2 braces, and then the current game data dot selected board data dot rows times square size dot y, outside of the braces divide by 2, and then times 0.01f. Okay, so this is the calculation we need to do. And now let's calculate the start position of our grid. So start position dot x will be equal to, let's open the braces, and now we will use the ternary operator. So this is the same as we use using the f statement, but I think it's much cleaner, make our code a bit cleaner. So I will just open brace here, and then mid width position is not equal 0. So if the mid width position is not equal 0, we want to do, let's put the question mark, mid width position times -1 otherwise. So we will put this colon mid width position. Okay, so this is exactly as we will use the f statement. And then let's calculate the start position dot y will be equal to mid width height. Okay, and now let's return. So let's open the braces, and then start position.x is lesser than the get half screen width. So this is the function we will add in a second, times -1, or start position dot y is more than the top position. Okay, so we in this line of code we just checking if our grid going outside of the screen, and this is the function to calculate the half screen width, which is not implemented yet. So let's quickly add this function in. So right below, let's create the private float. Let's copy this name. So get half screen width, and then let's create a few variables. So float height will be equal to camera.main dot orthographic size times 2. Another variable will be float width will be equal to, and then I will pass the aspect ratio, which is 1.7f. So you can stick with the same number, times height times screen dot width divided by screen dot height. Okay, so this is gonna be our width, and then let's return the width divided by 2. Okay, so we have all of our function. Now let's complete our get square scale. So inside our while loop, so let's add the final scale dot x minus equal adjustment, and then final scale dot y minus equal adjustment. Okay, so we're gonna scale down, and then if the final scale dot x is less or equal 0, or the final scale dot y is less or equal 0. So if we have scale -1, we will do the final scale dot x will be equal to adjustment, and then final scale dot y will be equal to adjustment, and then we will return the final scale. Okay, and then of course outside of this while loop, so this is the while loop, outside of it we need to return final scale. Okay, so this is the complete function for the get square scale. So we're basically looping through the scales, checking if our grid will not go outside of the screen boundaries, and then if it's going outside, we're gonna scale it down until it actually satisfies all of these functions. And now let's actually spawn our grid. So if our current game data is not equal null, we will capture the square scale. So var square scale, and we will use our function get square scale, and we need to pass new vector 3, and I think my target scale will be 1.5, so 1.5f and then on the z I will pass 0.1f. It doesn't really matter because we don't work with the z scale. And now let's do for each var square squares in current game data dot selected board data dot board. So we will look through all of the squares in the board. And now we need to select the specific square with the specific letter. So as you remember, in our alphabet data, if I go quickly back to the Unity, let's hit compile. And in our data, alphabet data, game alphabet, we have put the representation of the letter and then specific sprite. So all of our sprites have a already letter in. So we need to select the specific letter based on the value which we have in our board. So for the Z, we want to select the sprite with the letter Z. Okay. So this is what we're gonna do now in our script. So let's go back to the script again. So in our spawn grid square function, we're gonna loop through all of the squares in the board. So now we need to put another for each loop. So for each, and we wanna loop through all of the letters in the row. So var square letter in squares dot row. Let's continue with this function. So first of all, I'm gonna capture the normal letter data. Will be equal to alphabet data dot alphabet normal dot find. And this is gonna be the data. Let's use the lambda function to grab the data, to compare the data. So data.letter is equal to square letter. Okay, so this is basically the lambda function. Okay, so this is the normal letter data. Let's do the same for the selected letter data. So var selected letter data will be equal to alphabet data dot alphabet highlighted dot find, and we're gonna do the same. Data dot letter is equal to square letter. Okay, and then let's do the same for the correct letter data. Correct letter data will be equal to alphabet data dot alphabet. Actually, I want to use this red letter when we select. So I will just pick from the alphabet wrong. We should probably rename this one to alphabet correct letter data, but it doesn't really matter. Dot find data dot letter is equal to letter data. Okay, so we just capture all of the alphabet, and now we want to check if we actually found something. So if you put any number, or if you made any mistake, or if you try to use the letter which you didn't put in our alphabet data, we want to obviously just display the error, and we want to stop executing of our code. So we're going to do that by checking if the normal letter data dot image is equal to null, or selected letter data dot image is equal to null. So if this is the case, we want to print debug.log error. So I will just put some information. Okay, so this is the error I'm gonna display. So as you see, I just informing the all fields in your array should have some letters. press fill up with random button in your board data to add random letter, and then we want to display which letter we try to find and we couldn't find. Okay, so we know what letter is missing from our data. So you can really print in this logger or whatever you like. I think this message is quite informative because very often I tend to forget to press fill up with random and I left empty spaces. So that's the reason why I put this information in. So now let's check if Unity editor. So if we are currently in the Unity editor, let's put straight away the end if. So if Unity editor dot editor application dot is playing. So if we currently in the play mode, we want to immediately stop because we don't want our project to crash. So Unity editor dot editor application dot is playing is equal to false. So this is the way to actually stop the editor. Okay, so this is if we cannot find the letter. So what happens if we find the letter? So we put it outside of this F statement of this code. We want to put the else. So otherwise, we want to instantiate our grid square prefab. So square list dot add, and we want to instantiate our grid square prefab. Okay, we are almost ready to display our grid, but I think this episode is quite long now, so I will just cut this episode in two parts. So this is the first part. We are almost ready to actually display the grid, so we're going to continue this implementation in the next part. So in the meantime, as I'm using the new code editor, please let me know in the comments if it's okay for you to actually watch me coding in the Rider, or would you prefer me to switch back to the Visual Studio? Because for me it doesn't really matter, but for you it might be a bit of different. So thanks for watching, and I will see you again in the next episode.